Now, a lot of people think additive manufacturing for the hobbyist in his garage who wants to just print little trinkets for around the house, but it's so much more than that. So what sort of industries are using this sort of technology?
Various. There's not that many industries that aren't using it anymore. So, I mean, predominantly for us, we see a lot of business in sort of automotive, medical, consumer, aerospace, in general industrial sort of applications now. But it's changed a lot over the years, that's it. So where it started out, as a hobbyist process, it's now gone way beyond that, and there's a lot of people using it, well, a lot more for part production now.
And I think if we just take a look at what you've got on show.
Yep.
I always thought of additive manufacturers being quite hard materials, quite brittle.
Yep.
And then you give me a stress ball.
That's it. That's it, yeah.
So how have we got to this sort of product?
So that's it. So that's a TPU. So what we're doing with this is we're trying to mimic the properties of, say, an EVA foam, for example. So if you've got an application where you're making midsoles, insoles, seating even, usually you'll use like an EVA foam, yeah? That isn't an EVA foam. So we're using a TPU, which is a flexible material, and with design software that creates these sort of lattice structures, it gives the same performance as an EVA for a certain shore hardness.
And I just want to say, I want to go from sort of one end of the scale to the other, because we've got this, which is quite relaxing. I'm not going to say I'm going to put it down if I break something.
Yeah.
But then you've got this half dome with such an amazing finish.
Yeah.
So what's the difference between them, and what would that be used for?
That's it. So you've got a raw finish there on the TPU part. For this part, this is basically an example of the type of finishes that you can apply to it. So that's hydrodip. So this is just a sample to show you that you can hydrodip the material as well. So there's various things you can do to it. Hydrodipping is one. You can obviously have the raw part, paint it, dye it, vapor smooth it. You know, generally the things that you could do to sort of normal nylon billet, you could potentially do the same thing to a HB printed part.
So essentially the options are endless on what you can do.
Yeah.
Now, I just want to talk about this part, because that's an actual finished part.
Yeah.
So what's it used for, and what part actually is it?
So basically it's used on the Matsuura CNC machines. It's basically a cover. Traditionally, you would have maybe injection molded it, but the volumes that we needed for this component were fairly low, yeah? So what we've done is 3D printed it. It's more cost effective, and we can make it totally bespoke to Matsuura.
Now, just to finish off, why should people be looking into this technology as well as the CNC machining?
I think that's it. I mean, we're just another way of manufacturing. We're not here to replace the CNC machining in any way. We're just a new one. It's not new anymore, but it's another way to manufacture. Where we've seen growth is in the replacement of sort of low volume bespoke applications where you maybe wouldn't justify going into CNC machining it or injection molding it. Yeah.
So the possibilities are endless with this sort of technology. And Joe, again, I'd just like to say thank you for your time. And really, people at home, as well as their CNC machining, should be looking into this sort of technology, not to replace, but to add on to.
That's it.
To give them the full range of applications.
Yeah, exactly.